all through chapter 1, we've been talking about ways to solve quadratics. And solving quadratics, we're finding the what? Somebody say it. When we solve a quadratic for x, what are we finding? Okay. Think graphically. The intercept. So we're finding where it crosses the x-axis, right? And we've talked about a lot of different methods for doing that. We factored and solved. We have completed the square. We've graphed and looked at the actual intercepts. But sometimes, we've taken square roots, right, and got a plus or minus. But sometimes the problem doesn't lend itself to do any of those methods well. And when that's the case, we can use something called the quadratic formula. Now, here's what you have to remember. All right, so here's what you got to remember. Before you start, your equation needs to equal 0.
Yes.
Okay. So we're going to have ax squared plus bx plus c equals 0. This should be really easy for you. Okay. This is going to be a plug and chug kind of thing. We don't like to use it all the time because it gets messy, but as a last resort, it's good to use. It's a little long. Formula's long, but
Over
2a. Yeah. All right, so the formula itself, what this does, this solves it for x for you. You don't have to factor and set each piece to 0. You don't have to find a good c. You simply plug in. So y'all ready for the formula? Because this is what you're going to have to remember. X equals opposite b. You wish it was that short. Plus or minus the square root of, wait, after you do this extra credit project, you'll never forget the quadratic formula. B squared minus 4ac all over, important that you put it all over 2a, the entire thing. What I was telling you we could do earlier, if we divided everything by the leading coefficient of a and moved the bad c over and found a good c, if you manipulated that until you got x by itself, you'd end up with the quadratic formula. So it's a variation of completing the square, but it's just already solved for you. Looks kind of nasty, right? It's really easy, though. It's really easy. It is literally plug and chug. So let's do an example. Then I want to tell you about the discriminant, and then we will talk about your extra credit. So let's say that I have, let me get a good one here. 3x squared minus 8x minus 9 equals 0. And you have to solve using the quadratic formula. Now be careful because you have to make sure it equals 0. So it may not equal 0 when you start, and you might have to force that, okay? All right, so first thing I want to do, and it may help you if you identify A, B, and C before you start. And if B is missing, what is B?
0.
What if C is missing?
0.
0. What if A is missing?
No, 5.
Well, if x squared is there, it's 1, but if the whole x squared term's not there, it's not a quadratic anymore, right? If that's not there, it's a linear equation. Yes? I was kind of tricking you a little bit. All right. So it equals 0. What is A?
3 to the second. I mean 3.
3. It's just the coefficient. What is B?
8.
Careful. Negative 8. What is C? Negative 9. You all with me? All right, so let's plug and chug. X equals opposite B. You're right. So 8 plus or minus. Remember that plus or minus means 2 answers. It means I'm going to have to work through the formula with a plus, then work through the formula with a minus. Square root of B squared minus 4 times A times C. And really watch your signs here, okay? And the whole thing is over 2A, not just the radical. All right, so order of operations, let's work under that radical first. 8 plus or minus the square root of 64. I got 2 negatives, so I'm going to have a plus here, yes? Yes, no, maybe so. 4 times 3 is?
12.
Times 9 is?
I don't know.
Yes, you do. 108.
I didn't do that.
Oh, 64 and 108. 172?
72, yeah.
Now, at this point, if this were a perfect square, I would want you to write out the perfect square and give me the 2 solutions that it has, okay? If it's not a perfect square, though, let's look and see if we can simplify it any. 4, 9, 16, 25. Put it on your calculator and see. Yeah, there's a list up here.
The 172.
The 172, just the 172, right. No, just the 172. And that radical is going to be real important. It's going to play a big role here in just a minute. So, is 172 a perfect square? No. Can I break it down? What goes into 172? Anybody? Come on, y'all. 172. Nope. Four and 43. 43 is nothing's going to go into that, so that's the biggest one. 2, what'd you say? 86? No.
Yeah.
What's 172 divided by 4 was 43. Well, it's the square root of 172 breaks down in square root of 4 and square root of 43, and the square root of 4 is 2. Like that. Y'all remember doing that?
Sure.
Back in section, what was it, 4, 5? Now I can simplify that fraction. Do you see how?
Yeah.
How? Yes, divide everything by 2. Remember, this is under a radical, so you can't do that. But I can change this to 4 plus or minus square root of 43. And you can leave it just like that. You don't have to break it down into the 2 separate ones, since that's not a perfect square. Patrick, if that is an awkward angle for you, you can turn that desk around. I'm sorry. You're going to have a crick in your neck. Do what?
Did you do it by 2?
I divided everything by 2. This, and this. Does that make sense to everybody? So understand that if you get something like, are y'all still copying that? I'll give you a second. If you get something like 3 plus or minus 2 over 5, I would want you to break this down as 3 plus 2 over 5 and 3 minus 2 over 5 to show the 2 answers, if it was a perfect square there. You could have imaginary numbers here. Do you see how?
Yeah.
How? It could be negative 43. So that's the next thing I want to tell you about that's very important. Y'all got that? Do I need to do another example of just plugging in like that? You sure? Okay, you gotta speak up now if I do. That formula, you'll remember the formula. Of course, all of it's very important, but this little part here that sits under the, my color didn't change, that sits under the radical tells us a lot about our answer. And if you think about the properties of radicals, it makes sense. This is called the discriminant. And a lot of times you'll just be asked to tell me what the solutions are going to look like based on the discriminant, okay? If you think about the discriminant being under a radical, what happens if you take the square root of a positive number? What do you get? What kind of answers do you get? Positive or negative, right? Do you all agree that if you take the square root of a positive number, you get two answers?
Yes.
A plus and a minus, right? So if you just plugged into this and it gave you something positive, then I could say I know I'm going to have two real number answers. Do you agree with that?
Yes.
Does that make sense? Because if you take the square root of a positive number, you get two answers. That's going to give me a plus or a minus there. What if whenever I did this, I got a negative number?
It's imaginary.
How many imaginaries? Two. That's one of those scenarios where the parabola never comes and crosses, has any x-intercepts there. Right? There's one other scenario that can happen. Think real hard. Can you think about what? Zero. If you get 0, how many solutions would you have? One. One real number solution, because what you would have left is just the opposite b over 2a. Good job. I know. The new seat's making you think better. All right. So let me show you an example of that, and then we'll be done. We'll talk about your extra credit. Let's say, you want me to stay here a second? Okay. Let's say I had and I said, tell me the number and type of solutions. I need to do what first? Put what? Get everything on one side. Make it equal 0, right? So I always want to try to work with a positive leading coefficient. It makes my life a lot easier. So what should I move where? Yes. Add 3x squared. What's A?
3.
B? C? Careful. Negative 10. All right. So if all I'm concerned about is the number and type of solutions, I don't actually care what the solutions are. I just want to know what kind, because I want to know, is it going to cross the x-axis twice? Is it not going to cross the x-axis at all, or is the vertex going to be sitting on the x-axis? So those are my 3 scenarios. So I need to plug into the what? What's it called again? For just the number and type of solutions. Starts with a D. Discriminant. Discriminant, okay? If I actually wanted to solve, I'd plug into quadratic formula, but if I just want the number and type of solutions, discriminant will do.
What is the thing for discriminant?
Excuse me, b squared minus 4ac. It's the part of the quadratic formula that simply sits under the radical. So how do you do that? If it asks you for the number and type of solutions. Excuse me. All right, so B is 6. So I got 6 squared minus 4, 3, negative 10. I can already tell what this is going to be without going through. I only need to know, is it going to give me a positive, a negative, or 0? Positive. Because 36 minus, then I'm going to get a negative there. It's definitely going to be a positive number, right? So how many solutions am I going to have, and what type? 2 real. Does that make sense to everybody? This is a plug and chug section. That's it. Y'all ready for your extra credit now? Can you tell how excited I am? Yay!